Today we will discuss the experiment on linear measurement using LVDT. LVDT long form linear variable displacement transformer, because it looks like a transformer. So it comprising of, this is a cylinder in which we have the primary and secondary windings. This is a kind of primary and secondary windings. They are included inside the cylinder, and this is a linear scale, and this is what your circular scale. So this is the micrometer. We are giving the displacement using this micrometer to this extension rod, which is connected to the core, which is placed inside this coils, primary and secondary coils. The display you are observing, you are to set the 0 for the display using the micrometer screw to adjust the 0 of micrometer to the 0 of the horizontal scale. Now we have set the 0. Now this is the null position of the LVDT, where we have observed a 0 reading. We have observed the 0 reading. So it has a two mode operation: null displacement and displacement. The displacement is of a 2 mode: left hand displacement and right hand displacement. Here we are observing the linearity and hysteresis in the instrumental readings. Now we will give the forward displacement, where this is the S1, this is the S2. So where S1 will be more active than the S2, so the output will be given by the instrument based on the excitement or excitation of the S1. Now we will give the displacement of 5 mm. So we have to be very proper while giving the displacement using micrometer screw. So you have to adjust the 0 again with the 5. Now this is the displacement of 5. So it reads a 4.7. It reads a 4.7 in the display. So there is an error of 0.3 mm. There is error of 0.3 mm. Now similarly we will go for 10 mm. Displacement, it is 10.5. It is 10.5. Then (15 mm), 12.9. 15 mm, it is 12.9. Sorry, 15.6. Not 12.9. It is a 15.6. Now last one is a 20 mm. Now the 20 mm displacement, it shows 20.3. The readings we are observing are more than what we are displaced. These results are due to the systematic errors. These results are due to the systematic error. That errors are because of the system wear and tear. Because of continuous of use, there is certain wear and tear of the instrument occurs, and that may leads in the systematic error. And that we are reflecting in the output. That is 20.3. Similarly, we will go back. This is for the forward reading. Now backward again. This is 20. Again 50 will check whether system is linear with no hysteresis or not. 15. It is 15.6. Previously it was shown 15.6 on the 15. That means it has no hysteresis. Hysteresis drift is 0. Drift is 0. There is no drift from the initial reading and the final readings. When we are repeating the experiment, we are repeating the experiment forward scale and backward scale. Then again we will go for the 10 mm. It is 10.5. In the first case, when we go the forward, again that time it was 10.5. Again it was 10.5. That means whatever the result that are shown by the instrument during the forward scale reading, that will be repeated in the reverse scale reading. So when such kind of thing happens in the readings upscale and downscale reading, it called as zero hysteresis. Is called as zero hysteresis. There is no change occurs in the readings of the instruments when the same quantity is being provided as input when it is taken as a forward or a backward scale. Finally, the 5 mm. It was 4.7. Initially it was shown 4.7, and for 0 it will be a 0. It is a 0.8. So this is how we are going to measure the displacement, linear displacement using the LVDT. So the output is in terms of the potential difference occurs due to the change in the potentials of the two secondary coils, primary and secondary, which are located here. Secondary was S2, secondary S1, and center is the primary. So difference between the two coil voltage is represent as the displacement of the core inside the coil. So in this way we have completed the experiment number 1, linear displacement measurement using the LVDT. So we'll see the calculation part in detail during our practical session. Thank you.